This is Dr. J. Mohan from EC Department, Institute of Aeronautical Engineering. Today I am going to discuss about the Laplace transform first section. In this topic, under signals and stochastic processing subject. Our presentation outline is derivation of Laplace equation, relation between the Laplace transform and the Fourier transform, inverse Laplace transform of periodical function, and reference. Laplace transform. Laplace transform is a mathematical tool which is used to convert the differential equation in time domain into algebraic equation in the frequency domain or S domain. If we receive for the any mathematical equation like differential equation, in the signal is like continuous time signal for x of t plus x of t minus of 1. So this is we take for the differential case. I should write for this differential values as here x of t minus 1. This x of t minus 1 is represented as first differential case. So previously we studied x of t minus 1 we called as a time shifting of one position in the right side. But this condition we consider with the differential equation, that is in time domain. So we take for the Laplace transform or S domain, it's converted as a frequency domain or S domain. In this case, if x of t is a time domain function, then Laplace transform is defined as L of x of t is equal to x of s. The integration of minus infinity to plus infinity x of t e power minus st dt. For example, we take for the causal signal. It consists of unilateral Laplace transform is applied, which is defined as x of t of Laplace transform is equal to x of s. That is represented as integration of 0 to infinity x of t e power minus st dt. So this means there is no terms present for the minus direction of minus infinity to minus of 1. It's present for the 0 to infinity only is there. So that's why this is we called for the interval of 0 to 1 is represented as unilateral. At the same time, the causal signal doesn't have for the future value. Only the present and the past values are present. So this case, the u of t is 1 when t equal to 0, t is less than or equal to 0. That condition only it's going to okay. 0 otherwise we take. So this u of t I call for the unilateral or causal signal of case. So the u of t is present for the 0 to infinity. Only the signal is present. That's why I wrote the signal of Laplace transform in the x of t is equal to integration of 0 to infinity x of t e power minus st dt. I wrote. We need to derive for this equation. Now I take for the Laplace transform is used to solve differential equation. It consider an linear time invariant system. It exists by complex exponential signal of the form I wrote x of t is equal to g e power st, where s is represented as a complex number. Now I should write for s is equal to sigma plus j omega. So s consists of sigma real value and omega imaginary value is going to happen. So here I mention sigma is real of S and omega is imaginary of S. So imaginary condition we use for the minus J1. Now we need to prove for the Laplace transform equation as in this case of L of x of t is equal to x of s. So this is equal to integration of minus infinity to plus infinity x of t e power minus st dt p root. Okay, we need to prove for this equation in the Laplace condition. But we taken for the LTI system, it's going to have for the response by convolution of input with respect of impulse response. In the convolution theorem, we wrote y of t is equal to integration of minus infinity to plus infinity x of tau h of t minus of tau d tau p root, or integration of minus infinity plus infinity x of t minus of tau h of tau d tau p root. Okay, this is represented as a convolution equation, or I should write y of t is equal to x of t star of h of t. Okay, so this term we call for the convolution when we studied for the signals. We derived for the convolution equation also. Now, here I taken for the LTI system. So LTI system in the sense linear time invariant system. It's going to satisfy for the superposition and homogeneity of the condition. So if satisfied both, then that system is called for the linear system. The linear system produces the output is represented as a convolution of input as well as of impulse function. Now here I write for the linear system. So this is LTI system. The response is I take for the h of t. It's given for the input is represented as x of t. It's produced the output is represented as y of t. The y of t is equal to convolution of input into impulse function h of t. This impulse function is called system function or impulse function. Okay, be represented by this one. So based on that condition, I write for the y of t is equal to x of t convolution of h of t. So if the x of t convolution of h of t, I rewrite the equation as integration of minus into plus into h of tau x of t minus of d tau I should write. Now we taken for the input is x of t is represented as a complex exponential signal, that is x of t equal to g e power st. G is represented as amplitude, e power st is represented as exponential cases. That s equal to sigma plus j omega. So the x value we need to substitute for this one from here. So the here then integration of minus into plus to h of tau, then x of t minus tau, one shift is going to happen. That's why I should write as a g e power s t minus of tau. So where the t is present, I should substitute t minus of tau. Here I substitute t minus of d of tau. Then again I can split this equation is like this form. So e power st t is that equation I should substitute for g of e power s t minus of tau is equal to g of e power s t e power minus of s tau. So I should shift. So this term is represented as like a input. Then I take it out from the integration outside. Then remaining portion dot integration of minus into plus b h of tau e power minus s tau d tau. This term I should write as a h of s, capital letter h of s. Now the output y of t is equal to g of e power st h of s. So this g of e power s we taken from the input. I substitute for here. Y of t is equal to x of t into capital letter h of s. Now where capital letter h of s is a Laplace transform of impulse function. The Laplace transform of impulse function I write here. Laplace transform of h of t is equal to capital letter h of s. So this value we find from the derivative, that is minus infinity plus infinity h of tau e power of minus s tau d of tau we write. This equation I should mention here. Then if we take for the Laplace transform of x of t, then I should write as a Laplace transform of x of t is equal to x of s. So here Laplace transform of x of t is equal to x of s. This value also is consist of the input response of x of t e power minus st dt. Now the s is represented as a complex variable. I should write as a s is equal to sigma plus j omega. Sigma is represented as a real part and omega we call as a imaginary part. This equation we consider as a Laplace transform equation of x of t. It will be represented as a capital letter x of s. Next, the relation between the Laplace transform and Fourier transform. Now I take for the continuous time domain. The signal is represented as x of t. Then the Fourier transform of x of t, I should write x f of x of t is equal to x of omega equal to integration of minus infinity plus infinity x of t e power minus j omega t dt. This Fourier transform we studied for the last session. In this case, x of omega is represented as a frequency value of x of t. Now we know if we take for the Fourier transform, the Fourier transform of the signal is represented as a time domain signal. Its produced output is represented as a frequency domain signal. That frequency domain signal x of omega is equal to integration of minus into x of t e power minus j omega t dt. If the x of t is a time domain function, then we take for the Laplace transform is defined as Laplace transform of x of t is equal to x of s. So see, compare with the Fourier transform and the Laplace transform. We called Fourier transform is capital letter x of omega. Here we call for the capital letter x of s. Say Laplace transform. This is equal to integration of minus infinity plus infinity x of t e power minus st dt. Now s is a complex variable and s is I represent as a sigma plus j omega. Sigma we called as a real part. Omega is called for the imaginary part values in the complex variable of s. Now the Fourier transform of continuous signal x of t I can write as the spectrum of x of omega is equal to the integration of minus infinity plus infinity x of t e power minus j omega t dt. As per the statement of inverse Fourier transform, the x of t is equal to 1 by 2 pi integration of minus infinity plus infinity x of omega, this is capital letter x of omega e power j omega t t of omega. Now I should substitute or replace omega's represented as a sigma plus j omega in the definition of Fourier transform. Now where the omega is present, I should substitute for the sigma plus j omega. See here this equation, take this equation, here is omega, instead of omega we should substitute for the sigma plus j omega. That is x of sigma plus j omega equal to integration of minus infinity x of t e power of minus sigma plus j omega t dt. Now, in this case, we should write for the inverse Fourier transform also. The x of t, this means inverse Fourier transform of x of omega is equal to x of t. This x of t is equal to 1 by 2 pi integration of minus into plus into x of sigma plus j omega e power sigma plus j omega t d t of omega. Then sigma plus j omega is denoted by s domain. Okay, denoted by s domain. So now I need to find for the relation between Fourier transform. That's why randomly I take for the differentiation in the s domain. That is s equal to sigma plus j omega. Then d of s is equal to sigma is represented real value. There is no effect. Then I have plus of this is 0 plus of j d of omega. Okay. Now I need for the j. What is it? That d of s divided by d of omega. I should write here. I write for the j is equal to d of s divided by d of omega. Then d of omega is equal to d of s divided by j. I should write. So here I need to write. Okay. Two condition. J is equal to ds divided by d of omega or d of omega equal to d of s divided by j. Then we can substitute here. So substitute for the Fourier transform condition. So instead of sigma plus j omega, we substitute for the s. At the same time, here also will be represented for the sigma plus j omega. We substitute for the s. So this x of t is a d of t may represent. Okay. Now the x of inverse Fourier transform condition x of t equal to 2 pi j integration of sigma minus j infinity to sigma plus j infinity x of s e power st d of omega. This equation is known as bilateral Laplace transform pair of or the complex Fourier transform pair. The Fourier transform pair is equivalent to Laplace transform. The evaluation of analog the imaginary axis of S-plane, Fourier transform is equivalent to the Laplace transform. Evaluate along the imaginary axis of S-plane, x of omega is equal to x of s. Now s is equal to j omega. The Laplace transform of the function x of t is equal to the Fourier transform of x of t e power sigma t, we wrote. Now the Laplace transform of x of t is equal to x of s. This is x of s is equal to Fourier transform of x of t e power sigma t, we wrote. So Fourier transform of sigma x of t sigma t I write as a minus infinity to plus infinity. The x instead of x of t, I substitute for the x of t e power minus sigma t e power of minus j omega t d of t, we wrote. So this is integration of minus infinity plus infinity x of t e power of, take it out for the minus value, then we write for the s plus of, sorry, this is sigma plus of j omega t. Okay, sigma plus j omega t, we wrote, d of t, right. So this is x of s. So as per the basic, we taken for the s equal to sigma plus j omega. Okay, so instead of that one, we write then x of sigma plus j omega equal to integration of minus infinity plus infinity x of t e power of minus st dt, we wrote. This value we call Laplace transform of x of t. Okay, Laplace transform of x of t is represented as a minus infinity plus infinity of integration x of t e power minus st dt root. Okay. So based on this condition, I should take for the x of t value is represented as a x of t plus sigma e power minus sigma t v root. Okay. Next, we go for the inverse Laplace transform. So if the Laplace transform x of t is x of s, that means I will write here. So Laplace transform of x of t equal to x of s. So if we take for the Laplace transform of x of t, we got for x of s. Here I mention Laplace transform of x of t is equal to x of s. Then x of t is called for the inverse Laplace transform of x of s. This value I should write for the mathematically Laplace transform of minus 1, that is the inverse Laplace transform of x of s equal to x of t. L inverse is called inverse Laplace transform operation. Now we need to prove for the inverse Laplace transform operation. Now I take for the x of s. You take for the Fourier transform, that is x of t equal to sigma e power minus sigma. Then x of t e power minus sigma t is equal to Fourier inverse transform of x of s. That is Fourier inverse transform of x of sigma plus j omega, right? So based on this case of inverse Fourier transform, I should write 1 by 2 pi integration of minus infinity plus infinity x of sigma plus j omega e power j omega t d of omega. Now in this case I take it out for the e power sigma t. Here this term, let's go for the left arm to right arm, that is called for the e power sigma t 1 by 2 pi integration of minus infinity plus infinity x of sigma plus j omega into e power j omega t d of omega. Now finally I concluded the x of t in the inverse Laplace transform is equal to 1 by 2 pi integration of minus infinity x of sigma plus j omega into e power sigma plus j omega t d of omega. Now I should substitute s values equal to sigma plus j omega, j d of omega equal to ds, omega d of omega equal to d of s divided by j. We should apply for this equation. The x of t is equal to 1 by 2 pi j integration of minus infinity x of s e power st d of s. Now the x of t represent as inverse Laplace transform of signal x of t. What is the Laplace transform of? The Laplace transform of x of t, I should write this is x of s equal to integration of minus infinity plus infinity x of t e power minus st dt v root. At the same time, inverse Laplace transform of x of s equal to x of t equal to 1 by 2 pi j integration of minus infinity plus infinity x of s e power st d of s. This is the two equation of Laplace transform as well as of inverse Laplace transform. Next, we go for the condition for existence of Laplace transform. Mostly it's go for the Dirichlet condition are used to define the existence of Laplace transform. In this case, the function I take for the f of t has finite number of maximum as well as of minimum. So here the x of t I consider as a function of f of t. This is going to happen in between the maximum value minus infinity to minimum value infinity. That is minus infinity to plus infinity. That is symbolically we may represent as the function of f of t as finite number of maximum and minimum. That's the first point. The second point, there must be a finite number of discontinuities in the signal x of t in given interval of time. So we take for the any time this time it's possible to have the finite number of discontinuity in the input signal. The next point of condition, it must be absolutely integrable in the given interval of time. The integration of minus infinity to plus infinity mod of x of t dt is less than or infinitive. This 3 point is represented as a condition for existing of Laplace transform. Next, Laplace transform of periodic function. The Laplace transform of periodic function can be determined as using the time shifting property of x of t minus of t is equal to e power st x of t. Before that, we take for the system function, the x of t minus of capital letter T is represented as x of t for all t. Okay. So based on this condition, we should take for the time shifting property of the signal x of t minus of t is equal to e power minus st x of s. Okay. So this case I consider as a causal periodic function x of t which satisfies the condition of x of t is equal to x of t plus nt. Okay. We take for the causal periodic function x of t which satisfied the condition of x of t is equal to x of t plus nt for all value of t is greater than 0, where t is the time period of x of t and n is equal to 0, 1, 2, 3, 4 up to infinity. The definition of Laplace transform, the Laplace transform of x of t is equal to x of s, then equal to integration of 0 to infinity x of t e power minus st dt. The above expression can be expressed as based on the periodic condition 0 to, that is x of s equal to 0 to t e power minus st x of t dt plus t2 to t, here it will be completed for the t, then it start for the t2 to t x of t e power minus st dt, then 2t to 3t x of t e power minus st dt up to will be how the how many length is going to happen for the signal, that is integration of n of t to n of n plus or 1 of t x of t e power minus st dt up to infinity is going to happen. Now this case what I am doing, we know the signal is represented as a periodic, that means x of t plus t equal to x of t we wrote. Okay. So based on this condition, integration of 0 to infinity x of t e power minus st dt, then here I included for the t plus of capital letter T e power st. So next sequence e power minus 2 st, you take it out, t plus 2t. Same like then you can write for the up to n, the x of t plus nt condition I write as a plus of e power minus n st, the integration of 0 to t x of t plus of n of t e power minus st dt up to is represented as infinity. We need to simplify. As a periodic signal, when x of t is equal to x of t plus t, x of t plus 2t up to it will be how the any level, we can represent as x of t. So where the x of t plus t, x of t plus 2t, we can substitute for the x of t. So here, see here x of t e power minus st, then e power st, it will be x of t plus t, I write as a x of t e power minus st dt. Then we go for the another case, x of t plus 2t e power minus 2s, integration of 0 to t x of t e power st dt up to it will be how the n position, that is e power n of st, integration of 0 to t x of t e power minus st dt I write. So now the signal is represented as a periodic condition. We can retrieve that periodic condition. Some of the portion is going to similar together for all equation. Then I take it out for the exponential value. The first condition there is no exponential, I write as 1 plus. Here is how the e power xt. Then I write for the plus of e power st. Then it will be take for here e power 2s. Okay, there is e power 2st. I write for the e power 2st up to e power nst. I make to for the bracket, and integration of 0 to t x of t e power minus st dt I wrote. So this equation is called for the unibilateral sequence. So this unibilateral sequence, it's represented as a plus, that is 1 plus of a plus a square plus a cube plus up to it will be have the a of n. So this value is equal to 1 by 1 minus of a, we write. Okay, here that is the term of a. This term of a is equal to e power of minus st, that is a1, a2 equal to e power of minus 2st. Okay, like that one we are going to take to simplify. Then I write for that entire case is represented 1, that is 1 by 1 minus of e power minus st. This I should modify 1 minus of e power minus st limit. Okay, so that equation I should write here, that is power of minus 1. So 1 minus of e power minus st t whole power minus 1, that is equal to integration of 0 to infinity x of t e power minus st dt we write. Then finally I concluded that x of s is equal to 1 by 1 minus of e power minus st x1 of s. So the x1 of s we called as a integration of 0 to in t x of t e power minus st dt we write. The x1 of t is a Laplace transform of the first periodic of time function. The equation represents the periodic property of Laplace transform. Up to this much I am going to discuss regarding to the Laplace transform. This topic I should follow for the signals and system, be Lethic, and signals and system of Wiley. So today we discuss about the Laplace transform, derivative of Laplace transform equation, relationship between the Laplace transform and Fourier transform, inverse Laplace transform periodic function, and reference. Okay, up to this much we can discuss. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.